Hi, today I'd like to talk about a C++ approach to solving the quadratic formula. And I'm going to do this in a class. I'll have a couple of videos. One video will do the class in as one program, and a second video will show you how to break it up into a header file and an implementation file. So it's pretty straightforward. The quadratic formula is ax squared plus bx plus c, where a, b, and c are numbers and they're coefficients of these values. So to solve the quadratic formula, we use this form here. This thing, b squared minus 4ac, is called the discriminant. As long as that's positive or zero, you're going to get real value solutions for the equation. If it becomes negative, if this becomes negative, then the square root of a negative number is an imaginary number. And this discusses that. I'm not going to go much further with that, except I'm going to show a nice little summary they have here. Again, this is a reminder. If you don't know it, then you might want to think about it a little more. So here, I have a positive number inside the square root, and I get, in this case, two solutions. Here I have a negative, rather a zero inside the square root. So I get, again, two solutions, but they're the same, or they're one repeated solution, same thing. If I have a zero inside the square root, I get one repeated solution. I'm going to show it as two solutions, they'll be the same. And then if I have a negative number inside that square root, that is, if the discriminant is negative, I get two complex solutions. So this website, purplemath.com, is quite good, and if you read that, it'll tell you everything you need to remember about these things. All right, so here's my first approach. I have a class, I call it Calculate Quad Roots, and I have two public members of the class, and they happen to be the constructors. They're very different constructors, and how they operate, they're very different, and I'll discuss that in a minute. And then everything else is private. So I don't want the person who's using my class to fiddle around with anything except the constructors. They have a choice of using two constructors. So the first thing I have in my private values are those coefficients a, b, and c. There are two ways I can get them in. One is I can call this first constructor, and that will prompt you to input them. The second is I can lay them out in my second constructor. Either way, whichever way you like, and I'll go through that detail. So they're the coefficients for the equations. x1 and x2 are the results for the real solution. And if they happen to be the same, x1 will equal x2, and that's it. And then if I have an imaginary solution, I get a real part and an imaginary part, and that's how I build it up. So that's what these three different sets of numbers represent, and that's what they're for. The program is fairly straightforward. If I use the first constructor, it's going to ask you for input, then solve the problem and output the results. If I use the second constructor, you'll have already given me the input and it'll just give out the results. There's not much operator interface in either case. Alright, then I have this double discriminant, and that's going to be the discriminant, that b squared minus 4ac. And again, I'm going to test that for negative values. If it's negative, I'll set the imaginary flag to true. If it is not negative, I'll set the imaginary flag to false. That will tell me which set of calculations I have to do, real calculations or imaginary calculations. There are a lot of ways to do this. This is the simplest. It may be a little less efficient than the cutest one you could make, but it's fairly straightforward. So I have an input. I have a solve the discriminant. If the discriminant is real, then I use solve positive root, solve negative root. If the discriminant is not real, that is imaginary, I solve real and solve imaginary. And these setters are typical setters I use for classes. In this case, they don't do much because the coefficients for the classes, that a, b, and c, can be negative, positive, or zero. So the setters can't do a lot of testing or anything else, but I include them in there just to make sure that I keep my object orientation in all the classes I develop. So that's it for the class layout. The main is pretty straightforward. I have, this is commented out, I have calculate quadroots, my problem. That creates an object, my problem. That when I create that object with that constructor, it's going to prompt me to input A, B, and C, give me the solution. That second constructor, I passed with the A, B's, and C's, and I'm not prompted for anything. It just gives me the results. So let's take a look at running this thing right now. So here I'm prompting for A, B, and C. And I think what I'll do is I'll put in a 2 for A. I'll put a 1 for B, and I'll put a 6 for C. I think that's going to give me an imaginary result, and it does. It's the imaginary result I get for solving this equation. All right. So now when I run it again, let me just change this. I'll take out these comments. I'll use the other constructor. You can choose whichever you like. And the other constructor, I pass the parameters in. Right. Do another build. And here with the pass parameters in, when y is 0, that's at the intercept point. There are the solutions. So that's how it works. That's how it works. It's pretty straightforward. All right, I'm going to quickly go through this thing. Now, I have my input function. That input function, if I use the simple constructor, that input function does something. And basically, here I have 3 variables declared, A, B, and C. I say, welcome to solver. I prompt you for the A. I store it as underscore A, and then I use the setter to set that A into set underscore A into A. Likewise for the B, likewise for the C. Again, the setters aren't much use, but it's there for the rigor of the class. Then the second function I have here is the simple constructor with no parameters. It's interesting. All this does is, remember what happens. A constructor makes, when you use a constructor to make an object, it makes the object and it runs what's in the constructor. So here, after the object is made, I invoke the input function, prompt for the input. That input calls this thing, sets the input into the variables. Remember, the class can see all those variables. I solve the discriminant, and then I print results, and this is the heart of the baby. And here's my other constructor, where I passed with the 3 parameters. I use the sets for A, B, and C, solve discriminant, and print results. Now, same here. The only difference is here I'm passing directly, here I'm prompting for input. Solve discriminant, I calculate the discriminant b squared minus 4ac. I say if it's greater than or equal to 0, it's not imaginary or the results, so I set that flag to false. Otherwise, I set the flag to true. Okay. Then I calculate the roots. I have calculate the roots, which is, this is for a solve positive root, solve negative root. And then I have, let me just jump back here, calculate roots, solve real. So I calculate the real part, and I calculate the imaginary part. So depending upon which that flag is set to, I use one set of these or the other, and you'll see that in the print. And let's look at the print. Here's print results. If imaginary flag is true, right, that's what that says, therefore I have an imaginary result. I calculate solve real, solve imaginary, and I output those results. And I concatenate that string with the value I, and you show that I there for imaginary. If it's not true, that means if I have a real solution, I then calculate positive and negative, and I output the x and the x1 and the x2. Again, if they're equal, you're going to get equal values here. That's it. And basically, the setters are what you would expect with setters. They're fairly straightforward. Okay, well, I'm going to show in the next video how to break this up into H files and implementation files. Very straightforward, very easy. But here's my quick solution to a quadratic formula, including imaginary numbers. Thank you very much.